to see about most recently used. Same reference frame. With that, you need to do with the frame size of 3. So first we need to insert same one. Here initially your frames are empty as per the previous thing. As like we see here in your FIFO principle, least recently used optimal page replacement algorithm. First we need to check whether the frames are empty and then insert each and every page in your frame accordingly. So first you need to insert 1 in your page, that is 1. This is your page fault. Then you need to insert your required page is 3. So check whether the page is present in your frame or not. There is no 3 is present here. So you need to insert 3. So 1, 3 and then this is page fault. Now we need to insert 2 in your frame. So 1, 3, 2. Now your frames are filled up to 1, 3, 2. First 3 elements are filled. Now you are going to see 4 is present or not. So 1, 3, 2. 4 is present here or not? No. So here you need to check whether same thing left hand side, but you need to use most recently used. That is, which one is used in the most recently. That is, as per the, you need to insert 4 means. Next you need to check 2, 3, 1. Which one is insert most recently means next to the element. That is, you are going to replace 2. That is, which is your most recently used. This is second most recently used and then this is your least most recently used. Least recently used. Now you are going to check whether this algorithm that is most recently used. That is, you need to replace the most recently used element. That is your 2. Next to 2, 4, that is 2. So you need to replace 2. So 1, 3 and then 4. That is your page fault because now only you are inserting 4 in your frame. So that is your page fault. Now you are going to check whether 2 is present here or not. 2 is not present here. So again you need to check most recently used element in this. That is your next to 2. That is your 4. So you are going to replace this 4. So 1, 3 and then you are inserting 2. So this is also your page fault. Now you need to check 3. Check whether 3 is present in the elements or not. Frame or not, that is, you have already 1, 3, 2. So we need to insert 3. 3 is present here. So that is going to be a hitch. 1, 3 and then 2. Now you are going to check whether 1 is present not. 1 is present here. So 1, 3, 2. That is going to be a hit. 1 is present here. Now we are going to insert 4. So check whether which one is the most recently used in here. That is next to left side, that is 1. So you are going to replace 1 with this element. That is 4, 3, 2. So that is your page fault. Now we are check whether you need to insert 2 in your reference frame. 2 in your frame, that is 2 is already present in this frame. So 4, 3, 2. That is going to be a hitch. Because 2 is already present in your main memory, so that is going to be a hitch. Now you are going to insert, check whether this 4 is present here or not. So 4 is already present, so that is also a hitch. So 4, 3, 2. Next element is your 1. Check whether 1 is present here or not. Here 1, 4, 3, 2. 1 is not present here. So you are going to insert least recently, most recently used element. Next to 4, that is most recently element is 4. 4 only most recently element. So you need to replace 4. So 1, 3 and then 2. That is your page fault because now only we have inserted 4 in the place of 4. 1 in the place of 4, that is going to be a page fault. Now you have to check 3. So check whether 3 is present in the frame or not. So 1, 3 and then 2. 3 is present here. So that is going to be a hitch. That is 1, 3 and then 2. This is your most recently used algorithm. That is, check whether the page is present, whether there is a, you need to check your left hand side. That is most recently used element. So that page only you are going to replace with as per the most recently used algorithm. So now you are going to calculate number of page faults. 1, 2, 3, 4, 5, 6 and then 7. Number of page faults 7. Number of page hits, that is 1, 2, 3, 4, 5. So 5 total number. As per the formula, hit ratio, that is hit ratio equal to number of pages divided by total number of reference string. That is number of pages is 5. Total number of reference string is this 12 strings are here. So 5 by 12. That is your hit ratio. 5 by 12 is your hit ratio. Now these are the page replacement algorithm we have seen so far. That is what is meant by paging. Paging is actually a memory management technique which is going to be whenever you are executing your program, your data has to be loaded from your secondary memory to your main memory. That is known as your paging technique. As per the each and every data has to be loaded from your secondary memory to your main memory. That is your paging concept. In this paging concept, if the frames are filled, that is your main memory is going to be filled. Now you are going to replace the existing page with your newly one. As per the page replacement algorithm, so far we have discussed in this video, that is FIFO principle, first in first out, and then least recently used, and then optimal page replacement algorithm, and then finally most recently used algorithm. Thank you. Now we see about first in first out. We have already seen the first in first out, that is first in first out, we are replacing the first page with if you are going to insert on new page, so replace your first existing page in your frame. So that is your first in first out. For this you are going to something, there is a to decrease the page fault. To decrease the page fault in first in first out, we have introduced the Belladus anomaly. That is, here you are going to increase the frame size. That is, we are already with the frame size of 3. But as per the Belladus anomaly, you need to increase your frame size up plus, that is 1, that is increment for 1 frame size. That is, you are increasing the frame size to reduce your page fault. So that is your Belladus anomaly. Belladus anomaly means to increase the frame size to decrease the page fault. That is one of the, here it is in Belladus anomaly has been carried out in FIFO principle only, not in least recently used, optimal page replacement algorithm, or most recently used. In this 3 there is no Belladus anomaly, but in FIFO principle only we have used this Belladus anomaly. That is, we are going to increase the page size to increase the frame size to decrease the page fault. So first same thing as per that, these are the reference string. So 1, 3, 2, 4, 2, 3, 1, and then 4, 2, 4, 1, and then 3. So, initially your frame size is 3. We have calculated the reference string for the technique. With the frame size 3 only, we have calculated for FIFO technique, and then least recently used optimal page replacement algorithm, and most recently used algorithm for the page frame size of 3. But now we are going to calculate this with, as per the Belladus anomaly, we are going to increase the frame size. That is 3 plus 1, that is your 4. So now we are going to frame size with 4. As per the Belladus anomaly, you have increased the frame size. That is 4. So first is to inserting each and every string. Here your string first finally. As per that, as we have seen so far, that like FIFO principle, FIFO, and then FIFO most recently used, and then optimal page replacement. Like that only we are inserting each and every pages into your frames. Initially your frames are empty. Now we are going to insert your 1 in your required page is 1. We are going to insert 1 in your first frame. That is 1. Next you are going to insert 3. Here the 1 is not present in your main memory already, so that is your page fault. Now you are going to insert 3. So 1 and then 3. 3 is not present already, that is your page fault. Now you are going to insert 2. 2 is also not present in your frame, so that is also your page fault. Now going to insert 4. 4 is also, here we have added one more frame size, so also we have added with the 4. So 1, 3, 2 with that 4. Okay, now we have checked with 2. Here also 4 is also a page fault because now only we have inserted 4. That is your page fault. Now we have to check whether 2. Check whether 2 is present here or not. 2 is present here. So that is going to be a hitch. Now for 3, 3 is already present, so that is also a hitch. Next for 1, 1, 3, 2, 4, 1 is also present here, so that is also going to be a hit ratio. Next 4, 4 is also present here, so that is also a hit. Now 2. Check whether 2 is present here or 2 is present here. So 1, 3, 2, 4. So 2 is also present here. So that is also a hit. See whether how many hits we have seen. That is as per the page fault. So far we have seen page fault as 4 and then hit ratio is 5. Hit is 5. This is one is the Belladis anomaly. To increase the page size, to decrease the page fault. As per the Belladis anomaly. This is the Belladis anomaly. This is one of the to overcome the disadvantage which is comes from your FIFO. As per the FIFO principle, we have many page faults here. So that to decrease the page faults only, we have increases the frame size to decrease the page faults as per the Belladis anomaly. So now we are checking 4. So 1, 3, 2 and then 4. 4 is also present here. So that is also a hitch. Now here 1 is also present here. So that is also a hitch. See how many hits we have seen so far. Next this is your 3. 3 is also already present. So 1, 3, 2, 4. That is also a hit. So here see the number of hits are increases as per the page faults are decreases. This only has for that Belladis anomaly. So this is one is the basic disadvantage. To overcome the disadvantage in your FIFO principle, we have started with your Belladis anomaly. That is one of the to overcome the disadvantage of FIFO principle. As per the FIFO principle, we have the multiple number of page faults are here. That is whether you need to check your some page required page as per required page in your main memory. Most of the pages were not present in your main memory whenever you are searching for that. So as per the FIFO principle. So to overcome this principle, so that is overcome the disadvantage which is in your FIFO principle, we have seen the Belladis anomaly, that is to increase the page frame size to decrease your page fault. So here number of page fault as number of page fault means 1, 2, 3, 4. And then number of hits 1, 2, 3, 4, 5, 6, 7, 8. That is your number of hits is 8. So hit ratio equal to number of hits divided by total number of reference string. As the same formula, hit ratio, number of hits divided by total number of reference string. That is number of hits is equal to 8 divided by total number of reference string 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is 8 bar 12. Four by 3, the hit ratio is 4 by 3. This is your Belladis anomaly. That is to overcome the advantage and disadvantage in your FIFO principle, you are going to increase your frame size. for the previous one, that is your for prefer principle, and then LR least recently used, and the optimum page replacement and the most recently used algorithm. We have framed the calculation based upon the frame size of 3, but in Belode's anomaly, we increases the frame size with the 4, then only we have calculated so far. See here, first one is your almost, first the 4 elements only we have found out the page fault. After that we have found out all the elements are present in your page itself. So all the